roughly 0.
Thank you very much. Thank you. Okay, so we go back here. Well, I have to plug in another number, so it's like -1. And this is difficult because how will I plot e to -1? Well, e to -1, where's my calculator so I don't have to change the screen. So e to -1, so I have here e, this is e, second and e, and I put power -1. Oh, -1. And when I press enter, I will get 0.4 roughly. So this is approximately 0.4. And if I plug in 2 or something else higher than 2, I have natural log 2, and I have to get a number which is 0.7. Roughly, it's 0.69. So this is pretty good. That's all I really need in this situation. Obviously, this is not a jump because both numbers are the same, but this will be a jump. This will be a full point and an open point. But because these two numbers are the same, it will be the same point. But this one is a jump. So now I have to remember how to graph e to the x. So I'm going to graph e to the x on the side for you. Please, this is a very important function. And you saw how difficult it was in the last 3 years or so, almost 3 years, right? Or more than 3 years. We were trying to flatten the curve because the cases were just going rampant. This is a dangerous function, right? It has a very fast rate of increase. So we wanted to see, okay, flatten the curve. We couldn't for a long time. So that's e to the x. Now natural log is the inverse function of e to the x. It's this graph. So this is natural log x. And they have to be symmetric. These two graphs are inverses of each other. They have to be symmetric with respect to y equals x. So please remember this picture forever, please. So again, I'm going to use 3 colors. You don't have to, but I want to make a point. So I'm going to use this, whatever this is, for e to the x. And I know that at 0 is 1, and it's a full point. So it's just this piece. Nothing else. I cannot go anywhere else, and I'll put this aside. Then the middle part is a linear function. So 0, -1 is this, and it's an open point. And 1, 0 is this. Initially, it's open, but then I start at the same point. And now finally, the last branch. So a 2 is whatever. You cannot extend the natural log this way. You cannot extend the linear function this way or this way. And you cannot extend the e to the x that way. It will not be a function by the vertical line test. Again, it's not required to use 3 colors. I'm using 3 colors just to make sure you understand that this cannot be extended, this cannot be extended, this cannot be extended. This is very clear. E to the x is on this, x minus 1 is on this, and natural log is on this. And that's carved in stone. So now if I ask you, is this function continuous? You will say yes, except at Dakota, except at what? Please unmute yourself and tell me what you think. It's okay if you're wrong.
At x equals 1, there's a
At x equals? At x equals? At x equals?
0.
At x equals 0.
Sorry, x equals 0, sorry.
No worries. Good. Now, I will ask, is this function differentiable? Yes, except at where?
I thought if it was not continuous,
Very good. So it's differentiable here, but it's not differentiable at x equals 0 because it's not continuous. What else?
So I just have a question. So, like, if asked, is this continuous? Would we say yes, except at x equals 0, or just say no, it's not continuous?
You can say it's not continuous, but you also have to say because it has a jump at x equals 0. Both are acceptable. Very good question. So what about differentiability? Landon, what do you think? Okay, Landon and Dakota went swimming tonight. Okay. Anyone else? Only swimming is allowed. If you do anything else, it's not. Talia, what do you think? Except that x equals 0 and
Y equals -1.
so this is at x equals 0. We're talking about x values. We're not talking about the y values.
Okay.
So when we say the function is continuous, we are looking at x values. So the function is continuous, but it's not continuous at x equals 0. But then it's continuous. The function is continuous from the left because the limit from the left and the function value are the same. So continuous from the left at 0, but not continuous in general, if you want to say, because it has a jump discontinuity at x equals 0. Now we're talking about differentiability. Is this function differentiable? And we already said no, or you can say yes, but except at x equals 0 because it's not continuous. And where else?
Is it x equals 1?
Yes, y. Excellent. Y at x equals 1 is not differentiable because there is one tangent here and another tangent here. How do we call this point?
Non-vertical tangent.
Was it like cusp or something like that?
Corner. Very good. And not at x equals 1 because it has a corner. It is continuous at x equals 1. But it's not differentiable because it's a corner. It doesn't have a unique tangent. It has two tangents, one here following the function and one here following the function, and that's not allowed. Good. Now, what if I have a function? Any questions for me, please? Any questions? Yes, any questions? Go. Yes? Say it again.
The corner. Could you show the corner again?
This one.
Mm-hmm.
A corner is like this, a corner is like this,
Okay. Okay.
a corner is like this. Any interruption where there are two tangents.
Thank you.
Thank you. Good. So now let's say we have this function. Let's say 2x minus 1 for x less than or equal to 0. Negative 3x for x greater than 0. Let me see. It has to be continuous, so I can ask the question. Okay, so negative 1. Negative 1 minus 3x. Okay, is this function continuous at 0? Definition of continuity at a point. Can anyone give us a definition of continuity at a point? Landon, again, are you with us? Dakota, are you with us? Okay. Anyone else would like to give us the definition of continuity at the point?
The limit of f of x as x approaches a from the negative is equal to the limit of f of x as x approaches a from the positive, which is equal to f of x.
Brilliant. So continuity at x equals 0. Let's calculate the limit of 2x minus 1 as x approaches 0 from the left. Let's calculate the limit of negative 1 minus 3x as x approaches 0 from the right. And let's determine f of 0. If they're all the same, then we'll say continuous at 0. If they're not the same, 1 or 2, doesn't matter, then the function is not continuous at 0. So can anyone give us this number?
-1.
Excellent.
Substituting 0.
Good.
X equals 0, sorry.
When x approaches 0 from the left, we get -1. As x approaches 0 from the right, we get
-1.
good. And f of 0, we get
-1.
-1. Since they are all the same, I will say continuous at x equals 0. But now the question is it differentiable? So let's find f prime of x. Can anyone, they are both lines. Can anyone find the slope of this line? Can anyone give us the slope of 2x minus 1? 2. For x less than 0, I did not copy the equal symbol. You'll see in a moment. Can anyone give us the slope of this line?
-3.
So now I'm asking, is this function differentiable at 0? In other words, I'm saying that at 0, on one side there is a slope of +2, and on the other side there is a slope of -3. On the left-hand side of 0, the slope is 2. On the right-hand side of 0, the slope is -3. Is this function differentiable at 0?
Wouldn't that be a corner? No.
Not differentiable at x equals 0. Good. Just for us in perspective, I'm not going to ask this question. I just wanted to discuss that. Not now, because we are going to have this later. Okay, so now we want to talk about limits. So they're on page 103, so that's in 2.3. So I'm going to share my screen. Let me see the time here. Oh, I'm still okay. Okay, we're looking at 2.3. Here it is. Don't forget the squeeze theorem. So let's work on a couple of limits. I'm sure we can read from graphs, right? We know how to read from graphs and identify limits. We already did that with the previous graphs. But now let's choose some limits, a couple of limits to work on, from 11 to 34. Anything we have not done? I think we covered it all, but I'm not sure. Okay, let's work on 26. And that's my page 5. So I'm going to copy 26. So this is limit as age approaches 0 from -2 plus age raised to -1 plus 2 to -1 divided by age. Okay, so let's work on this limit. I want to see what you come up with, everyone, please. I'm going to make it part of a discussion. We have several for tonight. I'm not restricting the time, but I would like us to finish in roughly 4 or 5 minutes at the most. And the discussion is open, so please enter your answer in discussion 1. Let me know if you have any difficulties or if you need any hint as a starter.
Is anybody else having issues with signing in to Canvas where it's asking them to like sign in like 3 times and then prompting
Yes.
for like, more? It is.
I thought it was just me. I can't sign it, so I can't even access the